Alright. Let's get started. Hello, everybody. Speeding at sea, it's me, Z. Or, as Mindforce suggests, it's more like speeding at Z today because I slept through my alarm and I hit snooze one too many times. Sorry if my voice sounds a little not so good. I have been facing this mild illness for the past few days. Maybe it's just that time of the year, but this illness is like a combination of a mild sore throat, just like mild congestion. Hopefully it gets better, but yeah, it's just like this mild sickness that's just been at the back of my throat. So yeah, fortunately I currently have Canis Minor, or Zybe, with me as some sort of solace. So yes, Zybe is with me right now. In fact, he's right in front of the microphone. He's saying like, woof woof, and beow, and so forth. How is everybody doing today? Uh-oh, illness got hands. Yeah, no, it's just that time of year, right? When things get colder. Sounds kind of rizzy. It sounds kind of lower. Yeah, no, my voice sounds much deeper than it does before. I don't know if you guys have tried this tea. It's called like Airborne. It's like this like tablet that you put into your water and it like fizzes up. It has a lot of vitamins in it. I've been drinking a lot of it. It's been helping me get a lot better. Yeah, hopefully it does get better. I was unfortunately thinking about canceling today's stream, but I think I'm in an okay situation. Husky Z? No, that's out of pocket. That's out of pocket. No. Okay, it does sound a little husky though. Also, if you guys haven't already, please go to the emoji suggestion channel and check out that epic emoji. I don't know if I can add custom emojis yet. I'm actually unsure. Maybe I'll take a look at this after stream. But wow, the new emoji that Eggy Nugget drew was absolutely spectacular. I will definitely add it to the Discord at least, which should be super cool. So yeah. Whew. Alright, are you guys in the mindset to code? Because I certainly am. Regardless of how sick or dead or zick I am, it is always coding hour. So, how about we get started? In the meantime, I do have an amazing question for you guys. This is so out of pocket. My question for you all is, if you had to choose one, which one would it be to play? Would you like to be an Amogus imposter or an Amogus crewmate? And as you guys vote, we're gonna get set up on the code, okay? Alright, fun little question to get those brain juices going. If you guys have any recommendations for teas or drinks that could help with like a mild sore throat or like losing my voice, that would be great. I've been trying to drink some like vitamins. I've been trying with like ginger root and so forth, but I actually don't like ginger at all, so I've been like force drinking it. Alright, let's get started. Okay, that looks right. Yes, ginger lemon tea with some honey. I definitely should try that. I need to look for some honey. Okay, so what are we doing today, you may ask? Today we are creating a binary classifier. So last course we looked over what a classification was, and now we're going to be working through this Google Colab notebook. I think the interesting thing about this course is that they do a really good job of sort of explaining concepts, but these notebooks are not as interactive as I may have imagined. But let's go through this and we shall see how it is. Let me write this down. Ginger lemon tea with honey. Hopefully it isn't as cold as where you guys are. Luohango. I don't know if I'm pronouncing that right, by the way. Specifically for sore throat. If I encounter that, that would be great. A minty tea? Maybe I should also drink that. You know, these are all great recommendations. Thank you so much. Good spoon of honey. That would also be spectacular. Yeah, hopefully it's not cold where you guys are at right now. I've also been keeping an eye out for the Hurricane Milton news, and it's just absolutely tragic how devastating it is. Like, it's like a once in a century type hurricane. I hope none of you are directly affected, but if you are, definitely wishing that all things are safe and that you are safe. I've been keeping an eye on the news, and there's like tornadoes and hurricanes, and oh my god, it's just like natural disaster survival in Roblox, except in real life, and it's just absolutely terrifying. I can't believe it's climate change or something. It's crazy how intense these hurricanes are. Yeah, no, exactly. And seeing it from space too. I don't know if you guys have seen like the satellite images from space, but it's like a behemoth of a hurricane. Yeah. All right, without much further ado, let's get started. Okay. My voice sounds so dead that I feel like it just sounds so much lower. Hopefully that'll be okay. Binary classification. You'll complete the following tasks. Examine a dataset containing measurements derived from images of 2 species of Turkish rice. Ooh. Create a binary classifier to sort the grains of rice into the 2 species and then evaluate the performance of the model. Okay. Very epic. This is me doing an okay sign, by the way. Okay. Create a binary classifier. Calculate metrics for binary classifier. How to compare AUC and ROC. So that was the area under the curve and something under the curve of 2 different models. All right, let's load the imports. Oh, I think I already may have done this, but let's do it again. Load the imports. Load the dataset. Once the dataset has been loaded via the cell above, select specific columns to show summary statistics of... Okay. Okay, so we're just loading this rice dataset. See the Kaggle dataset documentation, especially the provenance section. Okay. So, okay, so what this is doing is that we're getting the dataset headers, and we're using that to describe the dataset. So this is actually a new type of dataset that I haven't encountered. It's called the Kaggle dataset. So maybe some of you who are experienced in Python probably know about like pandas data frames, like NumPy arrays and stuff like that. This seems to be totally different, but hopefully it's pretty straightforward. Well, one good thing is that it seems to print out really nicely. Okay, so we have 3,810 pieces of data, and we get all these different values. Very cool. Okay. Task 1, describe the data. Let's answer the following questions. What are the min and max lengths of the rice grades? I think we can just go through the thing. So, length. Major axis length. So we're looking for major axis length. Well, the minimum major axis length is 145.3 units? I don't know what... Oh, I guess it's given in pixels. So pixels. And then max is 239 pixels. I think that's correct. Hi Z, sorry, I'm late in class. Hello Germanium GE. Oh, speaking of, we totally forgot to do attendance. My bad. This is why I need a TA for the class. Alright, if you're here, please put here into the chat. Or into class, I guess. I will be registering everybody's attendance. Attendance is mandatory, by the way, to class. No, not the Among Us symbol. Not the Among Us symbol. This is the classroom. This is a place for seriousness. I'm just joking. Okay, hello Eggy Nugget. Hello Vine Force. Hello Podchamp Senpai. Welcome into class. Germanium GE. You'll get a pass for being tardy today, but next time you'll have to get an out of school expulsion. I'm just joking. Wait, aren't all expulsions out of school though? Huh? Yeah, maybe that is the case. Okay, what is the range of areas between the smallest and largest rice grains? Okay, so the range... Oh, I guess the range is not here, but we just subtract the maximum minus the minimum of the areas. Oh, in no way am I subtracting these two numbers. It's 18,913 minus 7,551. If somebody has a calculator, that would be great. Because those are two big numbers. How many standard deviations, STD, is the largest rice grains perimeter from the mean? Okay, so I guess that's just asking for the standard deviation from the mean for the perimeter, which is 36. All right, let's see. Oh, oops. The shortest grain, yes. Has an area of 7,000, yes. Oh, so when they asked for the range, they didn't want us to subtract it. I don't know about you guys, but when you learned about range, didn't you have to subtract it? Maybe they describe... Maybe 11,358 pixels is correct. Thank you, Mind Force, by the way. I thought that when we had to do range, we had to subtract it. I don't know, maybe they just weren't an accurate definition. The largest rice grain is 2.6 standard deviations from the mean. How do they calculate that? I guess they subtracted the mean from the standard... What? 548. Oh. Oh, it says the largest rice grains perimeter from the mean. Oh, how many standard deviations? Orbeez, I have not been reading carefully. I got a question wrong. This is horrendous. So we would actually have to subtract the maximum from the mean and divide by the standard deviation size to find out what are the number of standard deviations. Sorry, Orbeez, I misread the question. I thought it was a subtraction too. Yeah, no. Also, hello, Cyan. That's such a cute name, by the way. I saw you Reddit are really cool. Keep it up. Thank you so much. Thank you so much for your support. Also, speaking of support, we are so close to 1,000 subs. That's absolutely crazy. 1,000 Orbeez in the classroom. If you think about it, that's like the size of a huge lecture hall. Maybe even 2 huge lecture halls. So yeah, that's pretty crazy. Okay, task 2. Try graphing 3 of the features in 3D against each other. Okay, wait, we could just write a feature name here. If we were to pick 3 features, it seems that major axis length, area, and eccentricity might contain the most information. Well, let's just do that. So, major axis length. Length, area, oop, and eccentricity. Let's try running this. Hopefully that works. Wow! Whoa, that looks like a sheet. Wait, this is so cool! That is so cool. Wait, it looks like fish scales in the center. Wait, this graph like adjusting is also so cool. That is so sick. Wow, it's just like cool to see like the 2 divisions and it just looks like a flat sheet that's like slightly curved. All right, wait, let me look at the results of the poll. Most people want to be crew bait. I see. I don't know, but I feel like playing as an imposter is fun, but I get really nervous. Speaking of Among Us, I do have a special new Among Us costume. Maybe I shall wear it for Halloween. Who knows? All right. Now that I'm all teed up, hopefully my throat will be a little bit better. Oh. Well, they already colored in this for us. This is the same exact thing. Me and MATLAB struggling to 2D plots while Google 3D plot. This is actually so nice. I'm actually wondering if this is a direct feature of the Kaggle data set that they described, or just Google Colab being like super epic. Because if it's the latter, that's so cool. Woohoo! Breakdancing. That's so funny. Okay, cool. Yeah, no, these online classes are so advanced. It looks great. While creating a model with multiple features, the values of each feature should span roughly the same range. If one feature's values range from 500 to 100,000, and another feature's values range from 2 to 12, the model will need to have weights of extremely low or extremely high values to be able to combine these features effectively. This can result in a low quality model. Oh, I see. So you have to normalize the features. This can be done by converting each raw value to its z-score. The z-score for a given value is how many standard deviations away from the mean the value is. Okay. Oh, okay, so we just did that in the previous exercise where we found how many standard deviations the maximum is. Okay, now normalizing numerical values. Is there a way to calculate z easily? Haha, calculate z, get it? This is all about me. What do you guys think my z-score is? Hello, Okami Rays. Good morning, Miss Z. Sorry I'm late to class. It's alright. I'm giving out passes for today, but next time you will get a suspension. So be careful. Z-score. Alright, let's calculate the z-score of each numerical column in the raw data and write them into a new data frame. Ooh. Ooh, okay. Ooh, this is a little hard to read. What does this mean? 0, 1, 2, 3, 4. So I guess those are just the rows. Now normalizing numerical values in the rice dataset by converting them into z-scores. What did these rows mean? So they copied the class into a new data frame, calculate the z-scores of each numerical column, and write them into a d. So I guess these are just all the z-scores? Why does it have so many rows? What do these rows represent? I guess they calculate the z-score multiple times for different features. Wait, let's look at the code actually. So they selected the d-types number in the columns. And then they selected the numerical features. Let's look at the rice dataset again. I'm actually curious to see what this is about. So the rice dataset seems to have all these different values. Maybe the 5 values are actually these 5 up here. The count mean, STD min, and then the max. Yeah, maybe. Of each numerical. I'm not really sure what the rows represent. Or maybe they're calculating it at each data point. Yeah, and then I'm not sure why there's 5 of them though. Wait, let's see. Each raw value to its z-score. But I feel like there's so many more data points than just these 5. This is a little odd. Yes, my z-score is actually 0. That could be a good meme. My z-score is 0 because I have a 0 distance for myself. Hi, sorry, I saw CL retweet. Oh my god, CL is absolutely amazing. Thank you so much for stopping by. Also, if you haven't already, please subscribe to CL. I guess her full name is Code semicolon Life. She does a lot of machine learning content. In fact, I think she's been doing a lot of machine learning coursework as well. And she's actually one of the people who helped recommend me this course and suggest how these streams should work. So she's been an amazing help. Please, please, please subscribe. She's an amazing VTuber friend. A suspension? I can use that for a car. No, I don't mean for a car. I mean for actual class. I'm just joking. Well, if you do need a suspension for your car, best of luck. Okay, if there's one thing that I do want to do a course on that might be taught by class yourselves, is how does a car work? Because I genuinely don't understand like parts of a car. I don't know what a suspension is. I don't really know what an engine is. Okay, no, that's not true. It's just I'm not as familiar with these terms as I probably should be. If someone could teach me about how car insurance works, that would be amazing. Is your sure the cosmic microwave background? Yes, it is. It is the first light of the universe itself. Alright. I guess what they did was they examined some of the values of the normalized training set. So they guess these are just a few examples. Okay, let's keep going. Set the random seeds. To make experiments reproducible, we set the seed. We plant the seed of the numerical random number generators. This means that the order in which the data is shuffled, the values of the random weight initializations will all be the same if the collab is run. Yes. So what that means is that when we set a random seed, we can actually retrieve the data and the order of the data again, which is very nice, very useful. Okay, to train the model, we'll arbitrarily assign the Cameo species a label of 1 and the Osmantic species a label of 0. So I guess they're doing that here. So for the normalized data set, if it's true, then they set the class as Cameo, and the false if the class is Osmantic. Ooh, this is really efficient code, by the way. They just did that in one line without iterating through the data. So what they did is that they basically set this mask of sorts, returning true if the class is Cameo. And then they sampled it 10 times to give us these examples here. Okay. We then randomize and partition the dataset into train, test, and validation splits, consisting of 80%, 10%, and 10% of the dataset, respectively. Okay, let's see what's actually going on here. Create indices at the 80th and 90th percentiles. Okay, so we figure out where the 80th and 90th percentiles are, and then we randomize order and we split into train, validation, and test. And so these represent sort of the divisions. Oh, the first 5 rows of the last split. So we're splitting the data and then we're sort of taking a sample of the data, and that's what's being shown here. So we have train, so we choose to train the 0 to 80th. We choose to validate the 80th to the 90th, and then we test the 90th onward. Cool. I guess it is randomly generated though. They're not choosing these based off of like the top whatever. These are randomly chosen data points. It's important to prevent the model from getting the label as input during training, which is called label leakage. This can be done by storing features and labels as separate variables. Okay, let's see what's going on here. So we train the features with the columns. We convert the data to NumPy. What exactly does this function do? Oh, it converts it to a NumPy array. So I guess I'm more familiar with working with NumPy arrays, so that's better. The validation features, we go columns. So what it seems like we're doing is that we're reinstating the columns. No, we're extracting the columns and setting it as a separate variable, and then we're converting the data, the labels, into a NumPy array. I feel like this makes sense, but I feel like there should be an easier way of doing this instead of creating like 6 different arrays. Well, let's see. To start with, we'll train a model on these 3. Okay, I'm hyped, guys. We're actually going to create a model. Let's go. The following code cell defines 2 functions. Create model, which defines the model's architecture, and train model uses input features and labels to train the model. Create model applies the sigmoid function to perform logistic regression. If you guys haven't already known, the sigmoid function is one of my favorite functions just because it kind of sounds like sigma, like a sigma function. It's a very epic function indeed. We also define 2 helpful data structures, experiment settings and experiment. We use these simple classes to keep track of our experiments, allowing us to know what hyperparameters were used and what the results were. Okay, cool. Ooh, now here is the nitty-gritty code. So this is what they created in haras in advance. So define the functions that create and train a model. We import data classes. And then this experiment is where we can get the final metric value. We create a model. So all these seem to be very internal to this thing called haras. I definitely want to check out the documentation later on. I think they give a lot of it already, so this is great. This is also amazing if you want to create your own model, and I guess if you have the code in advance. I guess the end goal for this entire course is so that we can make like a surreal meme generator of sorts. The X parameter can be a list of arrays, and so then we train the model. Amazing. I actually have a question for you, Orbeez. So, if you had to choose between a NumPy array, a pandas data frame, and I don't know, like a default dictionary, or I don't know, some sort of haras data set. If you could reincarnate as one of these, which one would you want to be? I'm curious to see. Vote. Vote, vote, vote. I would definitely want to be a NumPy array for the record. The NumPy array is very epic. I made a butter waffle. Are you guys having breakfast this morning? I guess it depends on your time zone. Oh, yes, no, the subscribe goal is a little delayed. I actually forgot to update it. It should be 9:42. Yeah, we are very, very close to the subscribe goal. So, if you know any friends, any family, any members, please tell them to subscribe. We must grow the class at an impeccable speed. I hope your butter waffle is delicious, by the way, Eki. I feel like my default breakfast is like a cup of yogurt and maybe some protein. Like a sausage or like a ham, whatever. I have no idea what any of these options are. Well, in that case, you should vote for NumPy array because it is the best form of data. Okay, but genuinely, these are just different ways to store data in Python. Do you prefer MATLAB or Python when writing code like this? This is actually the first time I'm writing code like this, but I definitely prefer Python. That's sort of like my native language. It's like my first language, I guess. Hi, Sub tonight. Thank you so much. We are very, very close to hitting that milestone. And hopefully I'll be a little bit better by then, in terms of health. And maybe I have a super duper special surprise when we hit that milestone. I saw Panda. I voted Panda. If only Panda's data frames were as cute as actual pandas themselves. You guys should let me know what your preferred breakfast options are, or if you even eat breakfast at all. I actually don't really eat breakfast at all. Maybe I should ask for breakfast pictures. Maybe I need to eat more healthily if I want to get any better. Okay. My preferred breakfast option is coffee. That is my preferred breakfast option too. No way. Okay, but genuinely, a cup of coffee is not nutritious enough for the first meal of the day. I drank a really good cappuccino yesterday, and I thought it would make me feel better. But if anything, it made me so jittery, and then I wasn't able to sleep, and then I got too little sleep last night. Yeah. Okay, let's define a plotting function. Okay. Plot a curve. So, okay. These are just creating the functions themselves. It is a source of soluble fiber. Rice or noodles? Ooh. I think eating rice is one of the best things for me. I don't know why, but my body just naturally just enjoys rice. When I was in Japan, I felt like I was at my healthiest because I was eating so much like rice and noodles and like a lot of good protein and so forth. I always have spicy salsa. Oh no. Well, for a second I thought your profile picture looked like salsa on toast, but I think it's actually a carrot. Why spicy salsa? If you ever get a chance, you should take a picture and put it into the food channel on the Discord. I want to see what that looks like. That's absolutely insane. I know some people who like to eat like kimchi in the morning, like the Korean fermented vegetables. But I feel like I can get behind that. I actually heard that eating spicy foods are probably really good for like your actual health. And I guess in the case for me where I'm like my nose is very congested, it like helps like open it up a little bit more. Fingers crossed next week you hit the goal. You're popular the last few weeks. Thank you, thank you. Honestly, it's been growing at an impeccable speed. I know a lot of people who find me through Reddit and those kinds of channels as well. So that's absolutely spectacular. Yeah, no, and a lot of the memes have been taking off. Eggy Nugget just provided my very first like actual like fan art, which was insane. I actually set it as my wallpaper on Chrome. It's absolutely beautiful. Okay, continue with the code. The following code specifies the hyperparameters, invokes the functions to create and train the model, then plots the results, including accuracy, precision, and recall. So these were previously parameters that we looked at earlier in order to sort of define the data and how well we're describing and training our data. So the classification threshold is set at 0.35. Let's plot this. Oh, there's a weird error, but hopefully that's alright. Oh my god, so many epochs. OMG. Ah! Ah! Whoa. Whoa. What is this? So, as we train on more data, the precision increases, the accuracy increases, and the recall seems to decrease. I actually sort of need a refresher on what these mean. So let's go back to the course. There's like a table, yes. So accuracy is a rough indicator of model training progress or convergence. Recall is when false negatives. Oh wait, hold on. Let's actually look at what it means. The proportion of all actual positives that were calculated correctly as positives. So also known as true positive rates. That's interesting. It seems to decrease as time goes on. But that also means that we're not actually classifying all the positives, all the actual positives as positives themselves. That's a bit of a word tongue twister. Then there's also accuracy. The proportion of all classifications that were correct, whether positive or negative. Okay, so accuracy I think is pretty epic. I mean, it seems to reach a point asymptotically, but I feel like it would be better if it was a little higher. And then this is the area under the curve that we described. Let's see what that's described as. Oh yes, I remember we looked at these last class. The curve on the right has a greater AUC, so we're just basically trying to find the better area under the curve. This seems to be pretty good, not gonna lie. This seems to be pretty good. But we can adjust the threshold, right? What if we change the learning rate to be faster? Let's see what happens. Woohoo! A wave of epochs. I can change the sky if you want it. Ooh, that would be so cool. I do like the sky how it is right now, too. Interesting. When we change the learning rate, the area under the curve is like really good. But I feel like this has moved down a little bit. Oh, they also changed the scale. This is confusing because they changed the scale of the y-axis. But this seems to be generally better. You can put it on a log plot to make it look worse. For the precision, but it just goes between 0 and 1. We could play with that too. Well, I guess, oh, they're not using numpy plotting, so we'd actually have to change the plotting function itself. Oh, there we go. So, X scale. Oh no, you mean Y scale? Log, like this? I hope this is the right one. Let's see what it looks like that. They are randomizing the data, so probably change each time you run it. Yeah. But the general trend should be affected. I mean, with a log scale, I mean, the bottom gets stretched out more, so it actually does look a little bit better. But I guess using a log scale to describe this plot may not be as appropriate because we're looking at area under the curve. Oh, wait. I just realized something. This plot is not the ROC. So when I was looking at the shape, I thought we needed a better, more rounded shape. But this, what's being plotted here is the ROC. The area under the curve is like the area under the curve. This is plotting the area under the curve. But I guess it's good that it's so high and it gets to that point much higher on. You can maybe put the graphing in a separate node so you don't retrain just to change. Yeah, no, I was planning to do that next, actually. That's a great suggestion. So we can have... Oops. Code here. Oh, what? Wow, that I didn't know that they have a generate with AI feature. Okay, so let's rerun this again, and then so that we can get rid of the graphs, and then yeah, we can just play around with here. I guess I'm wondering, do they have ROC as an option? Woohoo! Also, you're not being rude. Thank you so much for these suggestions. We're all learning together. Oh, I guess ROC is not an option. Yeah, I feel like the log scale is... It's alright. It's just, it sort of skews what these things look like. Whoa! What happened here? That's crazy. But I don't think it should differ that much between plot and plot. So it was high and then all of a sudden it decreased. Maybe what we should try doing next is setting the learning rate to what it was before and then adjusting the classification threshold. Yeah, so this is what we're sort of doing. So right now we have it set to here. But I think if we can even set it to like 0.7, That would be great. Let's see what happens when we do that. Hello, Boxcat. I actually don't know what log scales prefer for these things. Yeah, no, it's always very good to check. Whoa, this happened really quickly. It's always very good to check what scale you're using. Ooh. Well, I'm gonna get rid of the log scale first. Where is that? Oh, here. Okay, interesting. It's a lot more wobbly. I guess, is it healthy if the area under the curve sort of goes up like that? It's calculated across all passable thresholds. Oh, I see. So this is for the threshold that we set. So let's just look at this first. So it looks a little bit wobbly and it doesn't really seem to reach a good point asymptotically. Maybe that means that we set our classification threshold too high and it's not adjusting properly while training. Let's try 0.5 instead. Speaking of machine learning papers, have you guys seen that the new AI, the new Nobel Prize in Physics was handed to a scientist in AI? I'm absolutely like blown away by this, by the way, because the CS people do have their own like prize, the Turing Prize, and so a lot of people were just generally just really surprised that AI is like under physics now. But yeah, I mean, there's no changing the Nobel Prize results, but I think it definitely shows that nowadays you do need to have, like, CS and physics are really intertwined, if not the same. Whoa. Now it seems like they're all on top of each other. I think the different data points not necessarily as relevant to the data testing. No, I think this is pretty healthy though, because we also need recall to be pretty good, right? And they're all sort of approaching 0.9. So we can adjust the classification threshold to best fit our needs. I'm wondering if there's a way to best find the classification threshold, but yeah, we'll just leave it at that. I have to go now. Sorry for having no worries. Thank you so much for stopping by, even for a brief time. Yes, scientists. Using it, I think it'd be an F. Yeah, no, I mean, school policies about using machine learning tools and stuff like that are pretty insane. But I actually heard about a class where they actually encourage you to use AI. And what I mean by that is, like, the class is called, like, I don't know, it's like AI generation or whatever. And you're allowed to use as much ChatGPT as you want. I don't know what the purpose of the class is, and I'll have to look more into it. But I think it's showing how people want to expand on their ChatGPT skills, I guess. Really interesting stuff. Okay. At the end of model training, you ended up with a certain accuracy against the training set. Invoke the following code cell to determine your model's accuracy against the test set. Okay. So there's not... Okay. It appears that the model, which achieved roughly 0.92 accuracy on the training data... Oh. Still shows an accuracy about... Oh. Well, that's because... That may be because we actually changed the data. No, maybe? Because we were able to adjust the classification threshold. Can we do better? Let's train a model using all 7 features. Oh. Oh, they actually want us to code something. I totally just did not see that. Alright, let's get all of the headers. Wow, there's a lot of them. Maybe we just extract test data.head. And then we print that out first. Oops. Oh, do they not show the result? There we go. So, oh, I guess this is not really the best way to look at it, but so we have area, perimeter, major axis length, minor axis length, eccentricity, convex area, extent. Yes, and these remaining two aren't really data. They're more like booleans or words, so we could just do this. Boop. Yeah. Basically what we wrote. If I have AI what I said, I would be 10 times dumber than I am now. Honestly, there are some really good parts about AI. If you guys haven't already, you should check out Perplexity. I felt like that was the best one when it comes to like STEM education. It basically accesses the internet and can help you like search for things much faster than I found like Google, in fact. I remember being allowed to use a math solver and then I failed the class because I didn't remember. Oh no, yeah, no, don't be too dependent on AI, of course. You should definitely like, it's really important to learn things on your own, but yeah. Train the full feature model and calculate metrics. Woo! Oh! Ah! A wave of epochs! Whoa! Well, in that case, I think we did pretty good on the last model when we set the classification threshold to 0.5. Because again, all of these values, accuracy, precision, and recall, are above 0.9. Full feature. So now let's look at the data. Oh, now it's so much closer. So I guess the way that we can test is we do train and test loss and all these different values. And so that means that it has overfit less to the training data. That's a really interesting conclusion. Woohoo! Oh no, this is the last part. Does this hump mean that it's overfitted a bit? Maybe it did overfit, but over time it's reached this like equilibrium point. It has like just about just the right amount of epochs. I'm wondering to see what happens if we increase this to like 100 or maybe even 200 epochs. Will it just like jitter around? Or I guess one big thing is you're supposed to balance like the computational resources with the results. Maybe if you have a really big data set, doing 200 epochs would take like forever. And then doing 60 epochs is more reasonable. I mean, if you look at the data, it seems to be mostly the same value. Can you grok in like 1,000 epochs? Wait, that'll be fun. Let's run 200 first. I mean, even 200 is taking quite a bit of time. Woo! Well, I guess it wouldn't make a difference, right? Because even after like, I guess 60 is a little early, but once we get to like 100, it's just a straight line. So after that point, it's like the same result anyways. So if we did 1,000, it would just be a really long straight line. That's interesting. Want to run this again? Yeah, I guess we're really close to the actual thing. Weight decay. What do you mean by weight decay? Weight decay is usually needed for grokking as a rule of thumb. Evaluate the full feature model. Okay, yes, we just did that. Comparing our two models with our simple experimentation framework, we can keep track of which experiments we ran and what our results are. We can define a helper function below. Woo! So we looked at the metrics. So we make sure that we have all the data we need. We train the metrics, add a custom measurement. Okay, well, let's just see what this does. So it goes through the metrics, it goes through the experiments, and it plots a comparison between the two. Whoa. Okay, let's read this. Baseline and all features. Oh, this is really interesting. So let's look at the dots, the blue first. So for the accuracy comparison, so the ones with the circles, the dots, when we just have the baseline, it rises a lot more slowly. But when we have all the features, it sort of quickly reaches where we need to be. Grokking is a sudden improvement after like a very long time after a model looks like it has flattened or worse, overfitted and done worse. Oh. Well, I don't think this is a sudden improvement at all. It's actually quite gradual. I think over time it seems to just reach an equilibrium point. If we look at the stars next, the area under the curve also seems to be so when we have all the features, it obviously trades much faster and better. And we got our accuracy and the AUC to look the same. This plot is so satisfying, this bottom one where they all line up together. There does not seem to be a large gain in model quality when adding the 4 other features. Oh, so that's sort of how you interpret it. I guess visually it does look better, but I guess what they're saying is after a long period of time, they end up both reaching the equilibrium point anyways because a lot of the features overlap. I remember in the course there was a way for us to determine how much these features overlap. I think it's just by finding like the correlation between the two and seeing how strong of a correlation they have. And sometimes if they have a strong enough correlation, they can be basically interchanged one for the other. Yeah, sometimes way out to the right, it might bump up suddenly. Oh, I want to search this up. This is really interesting. Why does that happen? Because I feel like in a case like this especially, it looks really equilibrium. Also, it seems like we have just finished creating and playing with our rice binary classifier. Let's go. So that was actually this part of the classification course where we, oh no, it wasn't this part. It was the programming exercise. Which means, this is absolutely crazy to say, but we have finished the entirety of the ML model section of the course. Which means that starting from next time, we'll be working with numerical data, and then categorical data, and then data sets, and so forth. So this is so hype. Let's go. We made so much progress. Oh, it's an area of active research. If you have any interesting papers that you think that we should talk about, please send them into the I guess the engineering channel is probably the best for this. But yeah. Whew. This is so hype. Orbeez, how are you guys feeling? I feel like this was really interactive and also pretty fun to look at. I want to be a lot better at using the haras library that they suggested, which was what they used this time. And then maybe next time we can create our surreal meme maker. I was also thinking about continuing the course, but I think my voice is dying even more and I might actually go sleep for a bit. I'm making another butter waffle. Please take pictures. Those sound absolutely delicious. Also, looks like NumPy array has won. Kara's dataset is in last place. That's so sad. Hello, Crypta. I'm cramming for midterms. Oh, I can't even imagine. It's probably that time of the year, right? Take some resty. Thank you so much. Yeah, I'm hoping that I can feel better. If I still feel rough, I might have to cancel stream on Saturday. And I hope that this stream was also very fun, even though I do feel quite under the weather. I actually have a Zybe right here, right in front of me, to keep me nice and warm. Waffle quote, yes. I miss studying for midterms. That's insane. That's an insane statement. Yep, I'm gonna try to get a warm cup of coffee today, and hopefully I feel a lot better. Thank you guys so much for stopping by. Best of luck with midterms. Do you guys want to do like a study with me stream? I think this, if I feel better by this weekend, we're gonna finish Superliminal. Also, I've been thinking about that puzzle, by the way. I literally have written down every single possible option that it could be, and we're gonna go through it and experiment. And one of these is going to be right, I promise you. Best of luck, Crypta. What are you studying for? I should also, I think it would be really cool to have you guys don't know some people who have like studygrams? It's like Instagram, but for like studying. I think that would be really like aesthetic studying. It's a C# midterm. Oh! Oh no. Oh no, 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 no. Well, I am rooting for you. You will not be doomed. With the power of Z on your side, you will power through. I've never, wait, but you've taken the course, right? So it should be all right. C# is nice. Could be worse, it could be C. Wait, hot take, but I actually really love C++. I think C++ is one of the more interesting languages. Even worse, it could be like assembly, right? Even worse, you could be creating a GPU from scratch or something. It's going to be all right. I'm rooting for you. Okay. To wrap things up, thank you guys so much for joining. It's more like my props leave us to learn from YouTube. Oh no. Well, I think there's a lot of really good YouTube courses out there for C# and for coding in general. Wait, Eggy Nugget, Java's like pretty fun. I passed C# class. Actually, we need to do a tier list of coding languages. I don't know if you guys have heard of Rust. It's like an absolute cult. People who love Rust, love Rust. Everything vanishes after the exam. Your mind just evaporates. Assembly is a lot less to memorize than C++. Wait, seriously? I've actually never coded assembly before. I just have talked to people who have, and they have some very strong opinions about assembly and sort of how it works. I heard that Rust is like the efficiency of C++, and the libraries are like as good as Java, not Java, as Python. Really? C++ 14 expanded? When I first learned C++, we used like a library that was sort of like, how to explain it, like, we focused on only specific features of like the C++ library, so it wasn't like the whole entire language. So I guess if I want to learn C++ again, I would have to refresh myself. Actually, that might be an interesting course to do, a C++ review. Yeah, no, Rush users. I thought you meant Rust. I mean, you probably mean Rust. No, Rust is an absolute cult. There's so many interesting YouTube videos of people being like, yeah, why Rust is better than X language or Y language, and it's funny. I feel like the cult is working though. I actually want to learn Rust after watching all these videos. Yeah. Okay, Orbeez. This was absolutely spectacular. And next week we will play more Superliminal. And hopefully I'll feel better. I'll keep you guys updated in the Discord. I think I might actually try to go to sleep for a bit longer and see how I feel. But until then, thank you, Orbeez, so much for stopping by. And we should definitely continue chatting about Rust and different sorts of programming languages on the Discord. Whoa, I am really bugging out. Ooh, I'm like moving at 1 pixel per second. I think this is also demonstrating of how tired I am. So, yes. Bye-bye. Thank you guys so much, and thank you for the well wishes. On the next episode, we'll be tackling that puzzle. So, yes. Alright. Until next time, goodbyes. I shall see you guys later as I go take some Z's. Okay. Goodbye. Bye-bye. Bye-bye. Alright. Goodbye, everybody. Have an epic, pogging, amogasified day. Alright. I shall see you guys in the next one.